Welcome back. These are the examples for infinite geometric series. Example number 1, we're going to find the sum of the infinite series 2 times 0.3 raised to the I minus 1. First thing I need to do is find my a sub 1. A sub 1 is equal to 2 times 0.3 raised to the 1 minus 1. Anything to the 0 is 1, so a sub 1 is equal to 2. My ratio is right here, 0.3. If I wasn't sure what the ratio was from this formula, what I could have done is calculated a sub 2, which is 2 times 0.3 raised to the first, and then I could see what the ratio is by thinking about a sub 2 is equal to a sub 1 times r. So that would be 2 times 0.3 is equal to a sub 1 was 2 times r, and therefore r must be equal to 0.3. Now the formula for the infinite geometric series is S is equal to a sub 1 over 1 minus r. So now I just want to substitute the values I just calculated. A sub 1 is 2, r is 0.1. So I have 2 over 1 minus 0.3 is going to be 0.7. And 0.7 is the same thing as 7/10. This fraction bar is the same as division, so it's 2 divided by 7/10, which would be the same as 2 over 1 times 10 over 7, which means that the sum of my infinite series is equal to 20 over 7. Example number 2. Find the sum of the series 9 minus 3 plus 1 minus 3, and so on. And again, I know that I need to use this formula. S is equal to a sub 1 over 1 minus r. And this only works if the series is geometric and if the absolute value of your ratio is less than 1. A sub 1 is right here. A sub 1 is 9. And if I wasn't sure what r is, I can think again that a sub 2 would be a sub 1 times r. So negative 3 is 9 times r, and r would be negative 1/3. So all I need to do now is substitute in a, which is 9, and 1/3 for r, negative 1/3. So 1 minus a negative 1/3 is plus 1/3. So 9 over 4/3. And then I want to simplify this complex fraction. So that's 9 over 1 times the reciprocal, 3 over 4. So the sum of the infinite terms would be 27 over 4. Example number 3. This time we have a repeating fraction. I'm sorry, a repeating decimal. We need to write it as a fraction. What we want to do is think about this as terms. So if I think that a sub 1 is equal to 0.23, a sub 2 is equal to 0.0023, a sub 3 would be 0.000023. You see how I'm getting the terms of this series. Now a sub 1 is 0.23. I need to find r. A sub 2 is equal to a sub 1 times r. A sub 2 is 0.0023. A sub 1 is 0.23. And if I solve for r, I get 0.01. So back to this little formula again, a sub 1 over 1 minus r. That would be 0.23 over 1 minus 0.01, 0.23 over 0.99, and we don't want to leave the decimals in the fractions, so it's 23 over 99. Here's another repeating decimal. We're going to change this one to a fraction. Now, same logic. A is equal to, or A sub 1 is equal to 0.03. A sub 2 is 0.003. A sub 3. A sub 4. And so on. My ratio this time is 1/10. So when I use my formula, S is equal to A sub 1 over 1 minus R, I have 0.03 over 1 minus 0.1. So I simplify this. And remember, I don't want to have decimals with fractions. So that would be the same thing as 3 over 90, and it reduces just a little bit further. And we find that the sum of the infinite series is 1 over 30. The next problem we have is to find the first term of an infinite geometric series is a sub 1, which is 4, and the sum is 16 over 3. We need to find the common difference of the series. We still want to go back to the formula, S equals a sub 1 over 1 minus r. So that would mean 16/3, that's my S, is equal to 4 over 1 minus r. So if I just do product of the means equals product of the extremes, I can solve for r pretty quickly. 12 is equal to 16 times 1 minus r. 12 is 16 minus 16r. Subtract 16 from both sides. And I get r is equal to 1/4. And that's what I needed to find. We have one more problem. This one's a story problem. A ball is dropped from a height of 20 meters. Each time it bounces to 60% of its previous height. What is the total distance that the ball travels? So we have a ball. It's being dropped up here. From here, it's coming down. It's bouncing up 60%. It's bouncing down again, bouncing up 60, bouncing down, and so on until finally it's going to come to the end. Now, it's not going to go bouncing out like this. I just did that for a demonstration. It's just going to be going straight up and down. And we need to calculate what that distance is. So what I want to find first is how far is the ball traveling down. So the distance that the ball is traveling down is going to follow this formula. And my a sub 1 is going to be 20 meters because it's being dropped from 20 meters. My r is 0.6 because it's bouncing each time 60% of what the previous bounce was. So S is equal to 20 over 1 minus 0.6. And when I simplify this, I get 50. Now, sometimes people forget that when it's bouncing down, it's also bouncing up. That's also part of its total distance. So we need to calculate how far it's bouncing up. Now, the first bounce up is not 20. It's going to be 60% of 20. So my a sub 1 for bouncing up is going to be 12. My ratio is still the same at 0.6. So my total distance that the ball is traveling up would be 12 times 1 minus 0.6, which is 30. So the total distance traveled is going to be the distance down plus the distance up. So it's traveled a total of 80 meters. Thanks for watching.